Okay, so just to be a little more rigorous and introduce some more about the indexing of vectors, just so we become familiar with this. A lot of what's more difficult about MATLAB is keeping track of which values are stored where in various matrices, and you often end up working with high dimensional data. So it's good to become familiar with these things. So if we define this vector v to be 1, 2, 3, 4, 5, 6 with semicolons between each line, we know that we're going to get this vertical column vector here. And what would be returned if we typed v3? Lots of people saying 2. Someone saying 3? Any advance on 3? So the answer is 3. In those of you who've coded in other languages will be used to starting counting at 0 in computer science, but in MATLAB we always start counting at 1. So the first index of our vector is going to be a 1, the second index is going to be a 2, the third index is going to be a 3, so v3 will be 3 in this example here. Okay, so another trick you need to use in MATLAB quite frequently is this colon notation. What the colon will do is if we put it there instead of a number, rather than getting the third element, it's going to get every element. So a colon means get all elements of the vector, or the row, or the column, whatever we're talking about here. So if we type v colon, it's going to give us the whole vector. If we put numbers on either side of the colon, what happens is we get everything from the first index to the second index. So in this example, v3 colon 6 is going to go from the third element, which we've just decided is a 3, up to 6. So it'll go from 3, 4, 5, 6, and we will get 3, 4, 5, 6 returned. So this is a good way of getting little bits of your data out. You might be wanting certain key time points in your time course. And so you can use indexes either side of these colons just to get some parts of a vector. Now things become a little harder when we move up to two-dimensional arrays. We've seen before that you can access these by index, but just to be clear, if I define a large matrix A to be 1, 2, 3, 4, 5 on the first row, 2, 3, 4, 5, 6 on the second row, 3, 4, 5, 6, 7 on the third, etc., we get something that looks like this. Now remember that you can put commas between these numbers, and I encourage you to do so. I've been lazy here and I've done 1 space 2 space 3, but to be rigorous, you're probably better to put a comma between your elements that are within one row. Okay, so that we see that A does contain 1, 2, 3, 4, 5 in the first row, 2, 3, 4, 5, 6 on the second row, etc. So if I type A brackets and then get element 2, 5, what it's going to do is go 2 rows down, 5 columns across, 1, 2, 3, 4, 5, and so the answer it gets back is 6. So it's always going to refer down and then across, down 2 elements, 5 elements across, and so it gets this element 6 out. You can combine these things with this colon that we've just seen, so you can actually get small slices of two-dimensional arrays as well as one-dimensional vectors. So if A is this same structure that we've just seen, what we can do is get every element in column 4. So remember that the first index will tell us how far down to go, but because we've put a colon here, it's going to go all the way up and down the entire column. And the second index will tell us how far along to go, and so we're going to go 4 along, and we're going to get every element in the 4th column, and that's why we get 4, 5, 6 back. So it's going to go in the entire way up and down the matrix, 4 columns along, and we get 4, 5, 6, 7. If we do it the other way around, and we only go 4 rows down the matrix, but get every column across by doing 4 comma and then use a colon to get every element across, we can get 4, 5, 6, 7, 8 out, and we get this last row across out. So the colon will get every element in either the row or the column, depending on whether it's in the first position or the second position. If the colon is in the first position, it's going to get every element in the column. If colon is in the second position, it's going to get every element in the row. And then which row or column it gets is defined by the other number. So this gets every element in the fourth column, this gets every element in the fourth row. I know that's going to get a little confusing, and you have to always remember it's down and then across, and I still find myself to this day thinking in my head down and then across. But hopefully you can see where these numbers come from. And you can take it one step further and put numbers on either side of this colon just to get subsections of those rows and columns. So this final example will get the second to third row down and the second to third column across. So it actually extracts this little square matrix from the second to third row down and the second to third column across. And so what we get is this 3, 4, 4, 5 small square here extracted from our matrix A, and so that's why 3, 4, 4, 5 is returned. Does that make sense? That's a nodding. Awesome. So often in MATLAB, we're wanting to define a matrix, fill it with values. Perhaps you define an empty matrix and then you want to put all your data points in it using a for loop, and you want some placeholder value there ready to replace with your values. And that's where these two functions come in handy, zeros and ones. Zeros will create a matrix of zeros, ones will create a matrix of ones. This is often useful. We use zeros when we're trying to have a count of something. You start with 0 and you add 1 to it every time something occurs. We use ones if we're trying to find out some ratio of something, or if it's overexpressed or underexpressed, you might want to multiply this 1 by 1.1 or 0.9 or something. So it's good to have these ones as a placeholder sometimes. So what these zeros and ones function do is define a square matrix by default. If you only give one argument, it's going to presume that you want a square matrix of zeros and ones. So zeros 3 will define 0, 0, 0, 0, 0, 0 in both dimensions, and you get a 3 by 3 matrix of zeros. The ones command does exactly the same thing. In either of these functions, if you define 2 arguments, so you give it a 2 and a 4, it will say that it's 2 down and 4 across. You'll notice this pattern's coming up, that it's always down and then across. So ones, 2, 4 will give you a 2 by 4 matrix of ones ready to occupy with values. If, like me, you're British, you'll keep putting an E in the zeros word and getting errors because it doesn't recognize that. So make sure you spell zeros the American way. Anyone not understand how that works? Awesome. And just to really mess with your heads, things can get even higher, dimensional. And in MATLAB, we call it rows, columns, and page, which is when we come up to 3 dimensions. And for example, if I define my matrix equals zeros, 4 by 4 by 3, it's a 4-row matrix with 4 columns and 3 pages. MATLAB will display 1 page at a time. It tells me that the first page looks like this, the second page looks like this, and the third page looks like this. Notice this column notation coming in again. It's displaying every row and every column in the first page, every column and every row in the second page. So you can see that it's working entirely logically, the same way we have been doing before. And this is, for example, how you would index these things. So this element would be first row, first column, first page. This element would be first row, first column, second page, etc. So for example, if we wanted to update this value to a 7, right now it's a 0, let's try and make it a 7. What we would do is we would do my matrix, we would open a bracket, and then we would need to think of the index, and the index would be 4 down, 3 across, second page, so 4, 3, 2, and then we would set that equal to 7. So that would look like this. My matrix 4, 3, 2 is equal to 7, And then because I didn't put a semicolon at the end of this line, it's told me everything that's in my matrix now. And it looks exactly like it did before, except for this element that's in the 4th row, 3rd column, 2nd page is now a 7. So here's another command to edit the matrix. If I run my matrix, colon, colon 3, and I set that equal to 1s with a size of 4, what's going to happen? What will my matrix look like after that? Someone shout out to me what they think it's going to look like. So if I run this command here, where my matrix colon, colon 3, and I set that part of the matrix equal to 1s with a size of 4, what's it going to look like? What do you say? All elements of the 3rd page should be 1. Got some nodding. Anyone think anything different? So let's think about this a second. My matrix, every row and every column on the 3rd page I want to update. That's this part of the matrix. Every row, every column on the 3rd page I want to set equal to a square matrix of 1s with size 4. So it's going to be 1, 1, 1, 1, 1, 1, 1, 1, which is going to update this entire part of the matrix, or if you prefer looking up here, this entire part of the matrix to be 1s. So that looks like this. Once we run this, the 3rd page is now this square matrix of 1s with size 4. And so we have the 7 that we put in here, and we have the 1s that we put in here. We started with a matrix of entirely zeros. Everyone follow how those numbers get updated? So, yeah.
You can't replace every one of those elements with a matrix.
You can't nest matrices in matrices like that. You can, if you use cell arrays, put other data structures within each other. But for a matrix, every element has to be some number. Yeah, that's why cell arrays are handy. You know, sometimes you do want to do that. Sometimes you want to have more information at each point. Great. Okay, so another thing that's super handy in MATLAB that is often more advanced in other languages is that you can sort arrays with just a simple sort command. So let's say I'm defining this new script here. Again, notice I'm in my editor. I've hit this plus button, or I've hit new script, and I've just put a few commands all after each other in my text document, and I'll run this by hitting the run button or typing sort test. I'm defining a vector to have these numbers in it, 23, 45, whatever. I'm then running sort v, and didn't put a semicolon at the end of the line because I want to see the result. And what you'll see happens is that I get v, which looked like this, back in numerical order. So just by typing sort v, I now get v in numerical order. If we try this on a multiple dimension array, we actually should tell MATLAB whether we want to sort it column-wise or row-wise. So if we define M to be 264, new row 539, new row 201, it looks like this, 264, 539, 201. If we then do sort M on dimension 1, what we find is that every column is sorted into ascending order. So we have 225, 036, 149. You'll see that this was 491 and now it's 149 down the column. If, however, we wanted to sort every row into ascending order, we could do this. We do sort M and then pass the argument 2, which tells it that we want to sort M in the horizontal direction, and you'll see that every row that was 264 is now 246, 539 is now going to be 359, so every row has been sorted into ascending order. So this automatically, so with the 1 and the 2 we specify which direction we want to sort.